looking live. All right. We're looking at scripts in more detail. So we know how to create a script, make it executable, run the script. And all we're doing so far is just running things that we would type at the command line. Now we're going to start looking at some of the things that make scripts flexible and useful. And one of those things is variables, positional arguments or parameters, things that allow us to not just write a script that does one thing, but writes a script and can actually change its behavior based off of like an argument that you give it, for example. All right, so variables, as I mentioned at the end of the last class period, basically allow us to store pieces of text that are going, that we're going to want to use repeatedly. So here's the syntax for using variables. If you've done any programming at all, this is going to look very familiar, but there are some peculiarities or some things specific to the shell that we have to make sure that we keep track of. Has everybody done programming other than Joey? Have you programmed any, Joey? A little bit? Okay. Oh, with Gavin? Yeah. Yeah, all right. So you know how to, this syntax will look familiar. Yeah. A variable name is equal to some value. The thing that's important here is that you cannot have spaces between the variable name, the equal sign, and the value. That will cause problems. If you have spaces in your value, you're going to have to quote the value, right? So if you don't have spaces in your value, then it's just simple x equals value. If you have spaces, you need to quote that. You cannot have spaces between the variable name and the value and the equal sign. So if you do a space between the equal sign and the value, you get something that says value command not found. If you put one between the variable name and the equal sign, you get something that says command not found for the variable name. So what's going on here? Well, the shell is what's interpreting this script, right? Everything that we run in a script is getting interpreted by the shell as if we typed it in at the command line. How does the shell figure out what the command name is and the arguments are? Well, it breaks it up into words based on spaces. So in this case, the shell is running into value and thinks that that's a command that it's supposed to be running. In the other cases, it's running into X and thinking that that's a command that it's supposed to run, right? You could have a command named X, which took arguments. The arguments could have equal signs in their name. That would be perfectly valid. So in order to tell the shell that you want to actually set a variable equal to something, you can't put spaces around it. And that's particular to Bash. It's not true of any of the other programming languages. And the reason is because Bash is doing other things with it's interpreting commands and running them. So it has to have a way of determining whether or not you're trying to set a variable equal. So that's how you set the variable equal to something. The other difference between, like if you've used Python or C or C++, is that the variable name by itself is not used when you want the value. You actually have to put a $, curly brackets around it. So the variable name with $, curly brackets around it expands to the value of the variable. So for example, I've got a variable here called message. I'm setting that equal to hello world. Hello world has a space in it, so I have to put that in quotes. And then I'm going to echo that variable. And the way that I echo the value of the variable is a $, curly brackets around it. If I just did echo message, it would just print out MSG, right? And so this is how I get the value of the variable. Now it turns out that just a $, in front of the variable name is a shortcut, and you can use that. Sometimes you need to have these curly brackets to delineate what's the variable name and then what's this text that you're going to actually put it in. All right, so first thing, let's update. Everybody should have a download and untar today's sandbox script, right, that uses the date command and variable substitution. So let's update that script to use a variable. So instead of inserting $ parentheses date twice, set a variable equal to the date string that you want to put in, and then use the variable to insert that. Now, there's a couple of reasons, you might ask, well, why would we want to do this? Well, I mean, honestly, for this script, probably there's no reason to do it other than learning how to use variables correctly. But if you ever have to make a change to the date format, like we find out that Corey has found a shortcut %F, or if I change the date format, right? Maybe I just want to do it to be to make you have to change your script, let's say. Well, then you only have to change it in one line. You don't have to go through every place that you called the date command to change it. That's a really good reason, especially for big scripts. And then another reason that could be a problem, especially with the type of things that we're hoping to accomplish this semester, is that you might have a command that takes a long time to run, and you don't want to run that command multiple times if you don't have to. So you can run the command, get its output, set a variable equal to its output, and then use that output multiple times. All right, so let's do that. Let's update our sandbox getter to use a variable. Yeah, I'm going to do that. All right, so variables are going to be useful. Anytime you are going to have like a string that's repeated multiple times, I typically use a variable just to make it easy to change that script if I ever need to. A couple of things you can do with variables. So these are just, this is just like different ways of using variables. Variables can be expanded inside of text. So the shell, the shell is basically designed to build text strings that are going to be either written to files or ran as commands or something like that. So this is built-in stuff. If you tried to do this with Python or C++, there'd be a lot of extra stuff that you had to do in order to get this to work. But for example, let's say I have a variable that I'm going to set equal to 10. So num is equal to 10. And then if I echo a string and I embed this $ curly brackets num, the shell is going to replace that with the value of that variable before it echoes it, right? So I can build up strings that contain values that I maybe don't even know at the time that I actually write the script. You can set variables with other variables. So if I say x is equal to 10 and then I set y equal to, this is just a value of x, then I'm going to get both x and y set to 10. And then here's me, so I'm using a variable for my message as well. So I've got message is equal to, I'm setting the message equal to a value that is some text. That text has spaces in it, so I have to put quotes around it. And then if I put variable names in there, so I dereference these variables inside, they will get replaced at the time that I create the variable message. And so if I echo then this variable message, I get x and y are equal to 10 and 10. I don't have it listed here, but if you, like, let's say that you wanted the string to not expand to the values of x and y. Like, let's say that you wanted to have $ curly brackets x in your string. Then you need to put single quotes around the string. So right now I have double quotes in here. If you change those to single quotes, then these will not be replaced with 10. That's a good thing to know, just so that you understand why sometimes you're going to use single quotes for something and sometimes you're going to use double quotes for something. If you want variable expansion to occur, which means variables that are referenced to get replaced by their value, then you got to use double quotes. If you don't want that to occur, you need to use single quotes. And then another thing you can do is you can just add, like, it's very common, this is what we're going to do with the path variable. It's very common to take a variable and then add something to it. So you can build sort of a string with a variable by referencing itself. So if I set message equal to hi, and then I set message equal to itself with my name is, this is just going to it's going to keep adding text to the message variable. So I don't have to worry about, this is not like the problem where if I try to write a file using input from that file, right? So if you use the greater than sign and you do file redirection to a file that you're going to use for the input, it'll get deleted before the command that uses that file gets the file. That's not the case here, right? All the stuff on the right-hand side of the equal sign is going to be evaluated before the stuff on the left-hand side of the equal sign gets it. So you don't have to worry about erasing the variable before you use it. All right, so the path variable. I've already mentioned this. This is the thing that I've got set up on mine that allows me to run commands that are in my bin directory. So when I type a command at the command line, the shell looks for an executable file that has that name. And it looks for that executable file in a list of directories. And the list of directories that is searched is in the path variable. And you can see what is in your path variable by echoing it. And you can echo it at the command line. So path is the name of a variable. So if I want to see what the value of that variable is, I have to do $, curly brackets, name of that variable. So let's see what the path variable looks like for me. So go ahead and do this. All right, let's check, make sure that everybody can see what their path variable is. My path variable is going to contain more things than yours, right? Because I've got stuff in here that I've added. You're going to see directory names. So these should all correspond to directories that are on your system. And directories are separated by a colon. So the list of directories that are going to be searched are in this variable, and they're separated by a colon. So I see things like /user, /local, /sbin. Apparently I've got some directories for games in here. I can get rid of those. Don't need those. /user, /bin. There's probably one that is just /bin, right? These are all of the directories that your shell searches for commands. So one way that I could make it look like there are no commands available is I can just set path equal to this. Now it says ls, no such file or directory. cd, no such file or, oh, that one worked. So if you erase the path variable, the shell doesn't know where to look for commands, right? You don't have to worry. I mean, anything that I change in this terminal is not going to be permanent. As soon as I close it, it's going to go away. And then when I open up a new one, everything's going to be reset. So let me see if my path variable, what it has in it now. Okay, so it has nothing in it. If I exit, open up a new one, now my path variable has all the stuff in it. Okay. Now what we want to do is, well, one thing I'll mention is that path is just one of several environment variables. So the system has the shell has a bunch of variables that have values in it that sort of give you information about the system. And so there's a lot of them. And the ones that would be most useful is the home variable. So sometimes if you're writing a script and you want to make sure that you copy something to your home directory, the home variable contains the name of your home directory. So mine is,
I didn't hear what it was.
I did not say anything, Google. So my home directory is /home/cclark. The user variable contains your username. That's useful sometimes if you want to write a script that is not just going to be used by you, like you might give it to somebody else, and you don't want to, if it depends on the username, you need to change that value when somebody else runs it. So my username is cclark. Another useful one is the variable named random. So if you echo random, you just get some random looking number. And if you echo it again, you get a different random number. So it's very easy to create random numbers at the shell in the terminal if you need. You just echo the variable named random. I think it's like whatever a 4-bit integer maximum value is. So it's like the 32,000 something, I believe. These are called environment variables, and you can get a list of all of the environment variables that are defined if you just use the env command. So this is all the stuff that is being set that the shell has access to, right? So there's a variable called shell that tells me that has the executable that my shell is using. There's a variable called path, right? Here's my path variable. There's a variable called username. Here's the home variable, right? So environment variables are very common to store information, and you can access those from your shell scripts if you need. All right, so let's modify our path variable so that we can use it to run any script that is in the bin directory. First of all, sometimes this is set up automatically. So if you are not in your bin directory, are you guys able to run the scripts that are in your bin directory? Can you test that? Like, so if you go into your home directory, so just type cd, and then just give the name of that script that you just wrote. Does it work? Or does it complain about a command not being found?
I think it complains. Pretty sure, because I tried that. Yeah. Command not found.
Okay, so if it doesn't work for everybody, let's go through how you would set this up to work.
should I just, you should have to move that to
All right, so I'm going to go to my home directory. And then what I'm going to do is I'm going to go into the bin directory and I'm just going to create a script that I can check to see if it works, just a test script. So I'm going to open up a file. I'm going to call it hello. I need to put my shebang in there. And I'm just going to have this thing echo tarball untarred. Oh no, it's going to echo hello world. All right, so now make this executable. And this just gives me a way to test if my path contains the bin directory, and mine does, right? So I can go to my home directory, type hello without this // and it's going to work for me. Yes, Tyler.
CD bin. It just says no such file or directory.
That means you need to create your bin directory. Right? So, or if you think you've created it, then you're either not in your home directory, or you created the bin in a different directory. So I'm doing this in my home directory. So if I go to, if I list the contents of my home directory, I have a directory here, bin. That thing wasn't there initially. I had to create that. And this is just a place that I store scripts that I want to use as regular commands. Right? Just if I want to be able to use them from anywhere on the file system. So let me see if mine works. Hello works. Hello world is there. All right, so to get your path variable modified, well, you could just set, right? You could just do it like this. You could do this from the command line. Path is equal to path. You need to put a colon, and then you do your home directory. And that would add it. I need to do something to make this, I mean, the details aren't really important, but basically in order to make that change affect everything that I start from this terminal, I have to export that variable. So I would do an export path. Now, the problem here is that any changes, even if I export them, any changes that I make in this terminal are going to disappear when I close that terminal and I start it back up. So what we really want to do is we want to put this in a place where every time we start the terminal, it's going to take effect. Okay, and so that's what we're going to do now. So go back into your home directory. There should be a file in your home directory called .bashrc. So BASHRC. The bash RC part, the bash means the shell, bash. And the RC part is just a common, I don't know exactly what it stands for, but it's a common name that's used for configuration files. So a configuration file for nano might be called .nanorc. Configuration file for bash is going to be called .bashrc. If this file doesn't exist, you can create it, right? Bash will look for this file. If it exists, it runs that file. So this is just a common naming convention, that dot so that it's hidden. That way it doesn't show up when you type ls. Name of the program that's going to read it, and then RC for something configuration probably. So open up that file, and if you're running the install that I suggested, which is Linux Mint, there's already a bunch of stuff in here. So this file already exists. This is just a shell script, right? This is just a shell script that is doing things based on the well, it's being read in by bash, and then these lines are being executed. This special file, .bashrc, that's in your home directory, actually gets loaded every time bash starts up. So when you open a terminal, bash starts up and it reads this file. That means if you changed your path variable in here, it would be changed every time you started up the terminal. So that's what we're going to do. So the easiest place to put it is just to go to the end. So I'm going to jump to the end. If you look at the commands here, Control V will go to next page. So that'll actually page down fast. Otherwise, you can just hit the down arrow. So I'm going to go down to the bottom. And I've already got the entry here. So this is what it needs to look like. I'm going to change the path variable. So I'm setting path equal to itself. with a colon, and then I'm using the home variable instead of typing out my my home directory, and then I'm putting /bin. So this home variable is going to expand to /home/cclark, and then I need to export that. So I have an export path. You can do these on the same line. You can export path and set it equal to something. You'll see that a lot of times. But the export part is required to get it to work for all subcommands. I think my script here is going to go ahead and add it. So I've got path is equal to original path, home directory /bin. And I'm going to export that path. And that's all you have to do. Now, this is only going to work for bash. If you use a different shell, you're going to have to do it for that shell's configuration file. But we won't have any reason to use another shell in this class. So you write it. It's not going to, what was that?
I can't find a path in my batch.
It's not in there. You got to make it. So you got to add it. So I've already done this.
I got you.
So this is what you need to put in there.
How do we get that? VIN.
Just do nano. VIM is a text editor. So if you change that and then you close and then you try to run your command again, you're still going to have it say that the command is not found. And the reason is because that bash RC file doesn't get read every time you type in a new command. It only gets read whenever it starts up. So what you need to do is open a new terminal. If you open a new terminal, you should then see that bin directory in your path. Yeah.
I don't know if this is a real question or not. But so every time you download a new tarball, is it gonna, if I didn't have a remove thingy in mind, so it deletes it right away?
Mm-hmm.
So if I didn't have that, would it save it in the bin? If I ran that from my phone?
No. So if you don't have any CD commands in there, it will save it in whatever directory you run the script from. So if you want to make sure that it always goes in the download directory, have your script CD into the download directory first, then download it, then untar it, and then any directory changes that you make in a script, like if you change directories in a script, when the script gets done running, you're still going to be it's going to be in the same directory that you ran. Like you can't change your current working directory from within a script. So that's what I would suggest doing, is just first command is CD, then go into the downloads directory, run wget, then run CD again to get to the home directory, then go into the sandbox directory. That way it'll automatically download it into the downloads directory and unpack it into the sandboxes directory. One thing that if you install some sort of program or something that modifies your bash RC file, sometimes it'll tell you that you either need to restart your shell or you need to source that file. So one way that you can make bash reread that bash RC file is to run the source command on that file name. So this will actually make bash reread that file, and then this change would take effect. But since it's in that bash RC file, if you close your terminal and open it up again, you should be able to run those commands. And you can check what your path variable looks like by echoing path. So is it working for everybody?
Yeah. So if I would do that like my home directory, it would save it to the bin?
No, it would save it in the home directory. Yeah. If all you did, if your command is just wget in the name of the URL, then if you run it from the home directory, it's going to save it in that home directory. But if you, in your script, you can change directories, and then that changes for the script what the current working directory is. All right. Everybody got that working? All right, let's see what else we got then. All right. So the scripts that we're writing so far have just done one thing, right? And we've done a couple of things to make them a little more sort of automated. We used the date command and command substitution to figure out the name of the file that we wanted to download for the sandbox. And then we used a very simple variable expansion to save the date that we want to use for the file name, and then reference that multiple times. Sometimes you want a script that will do something with some arguments. Like, for example, what we're gonna do is write a script that will automatically copy a directory to another directory with our username in it, and then tarball that, just like you'd have to do for homework, right? So we might call this pack homework. Well, what's the directory name that your script is going to use to package the homework? It depends on which homework you're using. So it would be nice if we had a way of saying, okay, well, I want to do this. I don't know what the name of the directory is yet, but I would like to write a script that can take that directory as an argument and then run these commands on it. And so that's exactly what positional parameters are for. So if you give arguments to your script, which you can do to any script that you write, right? Doesn't matter if your script actually uses the arguments. So I can type hello, I can give this is an argument, right? That's actually multiple arguments. It runs. So the arguments are being ignored. But what actually happens is the shell gives those arguments to your script, and you can use those arguments inside your script. The way that you use those arguments is you use variables that are named 1, 2, 3, 4, etc. So if your script has one argument that was given to it, it's going to be in $1. And this is just this shorthand, right? You can also put curly brackets around these numbers. So these are special variable names that you shouldn't use in your script. These are going to be handed to your script by the shell. Okay, so let's look at how that works. All right, I'm going to go to my home directory, and I'm going to create a script in the bin directory. And I'm going to create a script that's just called arguments. So this is just to sort of see how these positional arguments are handled. I'm going to just run touch on this file first so that I can create it, and then I can change it to executable before I start editing it. That way I don't have to open it up in Nano, save it, close it, change its permissions to executable, and then open it back up. Right now I've got a file that is executable, which means I can open it up in Nano, start making edits, and then run it from this terminal over here. So in this terminal, I'm going to go into the bin directory. It looks like I have a directory or a file named arguments. All right, so I need my shebang. Put the shebang in there. And here is where the echo command is useful, right? The echo command lets you see what things are going to expand to before they, they let you see what the shell is going to expand things to. So if you're inside of a shell script, the only way to see what something is going to expand to is to echo it and then just look at it, right? So I'm going to echo the word start so that I know that I've started. Corey and I both like to know something's happening, right? We want to see progress reports. All right, now I'm going to echo $ curly brackets 1. This is positional argument 1, and I'm going to save that. Okay, so Control O will write out, and I'm going to save that. All right, now I'm going to run arguments on the right-hand side. Okay, started, blank line. Give it one argument, start, prints out 1. Give it 2 arguments, prints out start, and just 1. So all I'm doing is printing out the first argument. What if 1, 2, 3 as a string was supposed to all be part of the first argument? I got to do quotes, right? So if I wrap this in quotes, then my script is going to get that string as first argument. So the shorthand is drop the curly brackets. So like I think I saw Corey writing, like you didn't put the curly brackets around date when you did your script, right? And that worked because the thing that followed $date was a period. But if you didn't have a period that told it that, hey, this is the variable name, like if you just had date tar, well, then the shell would run into the problem of trying to find a variable that was actually called date tar. And then the way that you would tell it that, no, it's not date tar, it's just date, is you'd put curly brackets around the variable name. So you can use the shorthand if it doesn't cause any problems. And it doesn't cause any problems if you have spaces or periods or any punctuation that come after the variable name. Let's make sure that this works. Okay, so that's the same thing as with or without curly brackets gives me the same thing. I can echo $1 and $2, and now if my script takes more than one argument, those both are going to be printed. So let's do a case where I'm giving it 3 arguments, 1, 2, and 3. So the first argument is 1, the second argument is 2. So I see 1 and 2 being printed out. Sometimes what a useful thing to do is, like, you want to see if there's any spaces that are actually in the argument. Like this is not, it's not even hardly possible to tell that this is actually the 2 arguments. How do I know it's not just passing these 2 words to the first argument? So I can put quotes around the variables, right? So here I'm doing in double quotes. So everything in double quotes will do variable expansion. And then around the actual variables, I'm putting single quotes. So what this is going to do is expand to a string that has the value of the first parameter and the value of the second parameter in quotes. That way I can actually see what is being passed as the first and second parameter. Save that, run it. I get 1 quoted and I get 2 quoted. If I do 1 and 2 as the first argument and 3 is the second argument, I get 1, 2 quoted, 3 quoted. Yeah.
So what if you want to print out, like, if you wanted to print out 1 and 2 on 2 different lines, but using 1 echo? Can you do that? Is there like an escape sequence for that?
Oh yeah. So it'd be \n, that'll print out a new line.
Okay.
But look at this. So we have not done anything special to tell our script to do pattern expansion. So let me just run my script with the star. I get it to print out stuff, right? So what does the shell do? The shell takes star, finds all the things that are in this directory, creates a list, and then hands that list to my script, and then my script gets those arguments in $1, $2, $3. And so the first things that pop up with star, it's sorting them alphabetically. All right, the first 2 things in that list are arguments and arguments.save, and that's exactly what got printed out by my script. So I don't have to try to program support for the pattern expansion in my script. All that's handled by the shell. All that's automatically available. That means I could write a script that tars up a bunch of directories and then just give the script a list of directory names using the glob. And then my script could go through, and for every one, it could tarball the directory up, following some sort of naming convention. Sometimes you want a list of all of the parameters that were given to your script, and so there's a special variable named star. So $star is going to expand to all of the variables, or all of the arguments, sorry, that were given to your script. So if I rerun the same thing, there's multiple arguments that are being given, and this last line here, which echoes all of them, is expanding to all of the arguments that were given. All right, that's all we have for today. We'll pick back up on this Monday. You guys have a good weekend. Good luck in linear. Is there a test? Good luck in your linear test.